Hi guys, welcome to our second video in chapter 15. This video is going to talk all about solution concentrations. So concentration is, of course, a measure of how much solute we have in a specific amount of solvent. So the table I have right here actually shows you everything we're going to learn for this entire video here. So this is the some of the most common ways chemists are going to quantify their concentrations. And we can see we have percent by mass, percent by volume, molarity, molality, and mole fraction. And so there they are. And it also tells you exactly what's being expressed, right? What ratio of solutes, what measure of solute to the specific amount of solvent. For example, if we look at molarity, we see it's measuring the moles of solute in the liters or volume of solution. Okay, so we'll go through these a little bit more specifically, but I also wanted to give you a visual example with these two cups of tea. We can see the lighter cup is, if these are the same type of tea, the cup that is lighter is generally going to be considered less concentrated than the darker cup, right? It's darker because it has more stuff in that same volume. All right, so I actually am going to start with our most important unit of concentration, and that unit is called molarity. We have dealt with molarity. We've talked about molar substances, molar solutions and stuff like that. So molarity, abbreviated as capital M, is the number of moles of solute dissolved per liter of solution. So of course, we are in Regents chemistry. This is a physical chemistry course, and so molarity is going to be our main unit of solution concentration. So this unit is the most important unit for you to understand out of all 5 of these options. It is molarity. That is the one you need to know, right? This unit right here. This is so useful for us because since it gives us the moles of our solute, and typically when we're doing chemistry, the solute is what's doing the reaction. Well, because it gives us the moles of solute, this leads directly into stoichiometry. So we don't have to play around. We already know, like if I have, for example, a 6 molar hydrochloric acid solution, I already know that I have 6 moles per liter. Okay, so let's look at how we would work an example involving molarity. Our question gives us that we have a 100.5 milliliter IV solution that contains 5.10 grams of glucose, and it's asking what is the molarity of the solution, and we know the molar mass of glucose to be 180.16 grams per mole. So quickly, I'm going to say, okay, our 105 milliliters of IV solution, that is our total volume of solution. So this, I guess I could call this volume. And then we also know that we have 5.10 grams of glucose, right? This is our solute. Okay? So I need to calculate how many moles of solute I have in my total volume. Well, with the skills we've done throughout our stoichiometry units, etc., this will not be too crazy. I start with my 5.10 grams of glucose. I multiply that by the molar mass, right? I said 1 mole of glucose has a mass of 180.16 grams. I'm going to get my grams of glucose to cancel, and I'm left with moles. And if I do this math out, I will find that I get 0.0283 mole of glucose. Okay. Well, now I need to divide that by the total number of liters of solution that I have. Well, I'm given milliliters. So I'm going to quickly say, okay, 100.5 milliliters times 1 liter over 1,000 milliliters. And I determined that this is actually 0.1005 liters of solution. So in order to calculate the concentration, I simply take my moles divided by my liters. So M equals mole over liter equals 0.0283 mole of glucose over 0.1005 liters of solution in total. I do that math out, and I'm going to get 0.282 molar solution. And that's my answer there. So make sure you can follow the math that I did there, but this is almost partially a review, this molarity stuff. It's just using units and fractional multiplication to get to moles and liters, and then just dividing them, setting them in a ratio. So though molarity is the most important unit for this topic, I'm sorry, the most important unit for this topic, we still need to talk about other units that we will see. Instead of describing moles per liter, often we will use percent to describe concentration. Two examples you may or may not have seen before are percent by mass and percent by volume. These are very straightforward percent questions where you take the mass of your solute and you divide it by the total mass of the solution, or do the same thing for volume. Volume of your solute divided by your total volume of solution. And then, of course, times 100. So let's look at an example. This asks us to calculate the percent by mass of a solution containing 3.6 grams of sodium chloride and 100 grams of water. Well, to do this, we simply are going to do the following. I'm finding the percent by mass, right? I'm going to do some highlights. Percent by mass, 3.6 grams of NaCl, 100 grams of water. Nice and easy. Maybe. We'll see. Percent mass equals mass solute over total mass times 100. Well, I have my mass of solute as 3.6 grams of NaCl over, and I need the total mass of my solution. So total mass is actually equal to the 3.6 grams of NaCl plus the 100 grams of H2O. And I find that that is 103.6 grams of solution. So I have, in this case, I have 103.6 grams of solution times 100. And I am going to get a total percent here of 3.5% NaCl solution. So that's how we would do a percent-based question. Again, just find the mass of your thing or the volume of your thing, and then find the total mass or volume of your solution, set them in a ratio, multiply by 100. Straightforward stuff. Again, just a simple percent calculation like we've seen many times before in class. Two more topics to discuss here. Diluting or concentrating solutions is something you would be asked to do very frequently as a chemist. When we dilute or concentrate a solution, we can actually calculate our final concentration of our solution using this formula here. And this is very applicable to like labs and very important stuff. So I'm going to put a star by it. M1 times V1 equals M2 times V2. And I didn't actually state this, but I say V equals the volume, M equals the concentration. Okay. So typically this is done using molarity, right? So we'll typically stick to doing this with molarity, but we can use this formula for any type of concentration. So let's look at an example. Let's say that we would like to calculate the final concentration of a solution, final concentration, that is a 6 molar solution of HCl that has an initial volume of 10.0 milliliters and is diluted to a total volume of 30.0 milliliters. So in order to solve this, I need to recognize that this is my M1, that this is my V1, and that this is my V2, and then I'm being asked to calculate M2, okay? So I'm being asked to calculate M2. So in my formula of M1 V1 equals M2 V2, I'm solving for M2. So I'm going to move that V2 over. It's going to tell me that M1 V1 over V2 equals M2. And so that would mean to plug in here, that would mean that my 6.0 molar times my initial volume of 10.0 milliliters divided by my final volume of 30.0 milliliters. And I'm going to get, an answer of 2.0 molar HCl solution. And I stopped and think to myself, like, does that make sense? Like, is that a reasonable answer? And okay, if I started with 10 and I added 20 more milliliters to get to a total volume of 30, that means I've increased the volume of my solution. So therefore I should have decreased the concentration. And we see that that is in fact what happened, went from 6 to 2 molar. All right, so let's talk about our last units that we have in solution concentrations. We need to talk about molarity and molality and mole fractions. Molality is the ratio of moles solute dissolved to 1 kilogram of solvent. It's very similar to molarity in the sense that molarity is dealing with 1 liter of solvent, but molality is instead dealing with 1 kilogram of solvent. So in order to calculate molarity, we would take our moles of solute and divide it by the kilograms of our solvent. So I do have an example of this, but I don't have enough time to go through and actually calculate all of this in this video. So instead, I'm going to give you guys the answer to this. And if you would like, you can go through and see if you can actually calculate this. But if we look at this example, it says, in the lab, a student adds 4.5 grams of sodium chloride to 100 grams of water, calculate the molality. Well, the actual molality of this is going to be 0.77 moles per kilogram. So if you'd like to solve this on your own, you can. That's awesome. Last thing to talk about is the mole fraction, denoted as X. The mole fraction is the ratio of the number of moles in a solute to the moles of solute to the total moles of solute and solvent. So I have those formulas down here, copied into your notebook, and we will work with this a little bit more in class. All right, guys, that's all I have for this video. Thank you for listening, and I'll see you in the next one.